All right, so we've got yet another periodic trend to think about, and this is electronegativity, sometimes abbreviated as capital EN. What electronegativity allows us to do is it predicts bond polarity. But we'll learn more about that later on. For now, it's just going to help us draw our Lewis structure. So what is electronegativity? Electronegativity is the ability of an atom to pull on electrons in bonds toward itself. So what you can think about, right, in these covalent bonds, we have these electrons being shared, but they're not always being shared evenly. So if one element is more electronegative than the other, when the two form a covalent bond, although those electrons are shared, they'll spend more time around the electronegative atom than they will the non-electronegative atom. So for example, if we have HCl, the chlorine is significantly more electronegative than the hydrogen. So if we think about electrons in terms of, densities instead of just these little lines, what we would look like is that the electrons in this bond would spend most of their time around the chlorine and just a little bit of time around the hydrogen. But we'll talk about electronegativity and its effect on polarity later on. For now, we're just going to help it, or just use it to help us draw Lewis structure. Overall, I would say that this is the most important trend, in my opinion. So let's go take a look at the trend. So we've got our sketch of our periodic table, right? Not my best one, but whatever. As we go towards the upper right, we get more electronegative. With some small caveats, we generally ignore these noble gases. So they're not very electronegative. And the reason that we ignore them is that they rarely form bonds. So if we think about the electrons pooling, or the nuclei pooling on the electrons in a bond, why do we get more electronegative? Why do we pull harder when we go to the top right? Well, if you think about it going from left to right on the periodic table, we're increasing Z effective. And so our electrons are going to feel that nuclei stronger, so they're going to get pulled more closely to that atom. If we go from down to the bottom to the top, we get smaller. And so since we get smaller, that reduces the distance from that electron to that nuclei, and that nuclei can pull on an electron more. So that nuclei is closer to the electrons, so it pulls harder. So if you think about what element is the most electronegative, it is fluorine, right? Fluorine is in that top right corner. Here's the same thing, just now with actual numbers and, nice diagram. You can see as you go towards that upper right, you get to the high end, right? You can see fluorine is the most, right? These three, there's no data on them because they rarely ever form bonds. So if we think about the most electronegative elements that we have, first it's fluorine, right? 3.98, and it's out of a scale of 4. After that comes oxygen with 3.44, then chlorine, then after that, nitrogen. So what you can see from that trend and the fact that oxygen is above chlorine, right? It's more electronegative than chlorine, is the same trend that we learned about the other ones. And that's the up-down, going up or down or through a group causes a bigger effect than going left to right or within a period, right? So even though both oxygen and chlorine are one step away from fluorine, since oxygen is in the same period, it is closer to electronegativity than the chlorine. And as I said, this is important for drawing Lewis structures. Which is why we need to learn about it now. And then later on, we'll learn about molecule polarity, which is also really important. And we'll come back to electronegativity. But this is just a quick precursor to make sure we have everything we need to start drawing Lewis structures.